Hello, I thought it might be interesting to make a little demo to see just how many different methods of radio control an S-bus mixer can handle at the same time, because it has quite a lot of inputs available. There are 3 UARTs, so they can be used for serial radio things like S-bus and I-bus. And then we can also use PPM, PWM, we have NRF24, and we can use the logging as an input to receive messages from a 915 megahertz serial modem. And well, let's just have a look at what we've got here. So we've got 3 FlySky receivers, and I'm not sure which is which, but they are I-bus, S-bus and PPM. Then we have the 915 megahertz, well, I was going to say receiver, but it's a transceiver. You can send both ways on that one. And down here somewhere we have a Dumbo RC, just a regular PWM receiver. Then we have the NRF24 there. And the 7th receiver is going to be this Raspberry Pi 0W, which has Wi-Fi capability. So our radios are over there. Again, I'm not sure which is which, but I-bus, S-bus and PPM for those 3. Then we have PWM, and this is going to be my transmitter for the NRF24. This is the old cheap-ass transmitter that I made ages ago. Has a NRF24 in it there, and I'm just going to use 2 channels. Not sure what happened here. It's been a long time since I used this. And then for the serial modem transmitter, I'm just going to make use of the fact that there's an accelerometer gyro on here, and I'm just going to tip it like that to control the steering. So I have to keep it flat if I don't want it to move anywhere. And then for the 7th one, what we can do over the Wi-Fi is we can connect to the Raspberry Pi, which is that, and then I can manually move these sliders here where it says tweak number. So they're at the middle of the range at the moment, but I'm going to be manually moving those to control the steering and the throttle separately, just as a demo of how that works. So let's give it a try. Okay, I have so many radios to deal with here that I have to make this sort of like an inbox and an outbox, so I don't get them mixed up. But let's start with this one. I think this is I-bus, and due to the way that the failsafes work on those FSIA 6B receivers, I had to make it so that this switch was also on. So it wasn't enough for the radio just to be on, because when I turn it off again it would keep sending signal to the S-bus mixer. So anyway, for that reason on these 3 radios I'm having to turn the switch as well. Anyway, so that's left and right, forward and back. Turn that off, put it in the outbox. This one I think is S-bus. I think this is S-bus. Like that. And then we have PPM. Pretty much the same thing. Come back this way a bit. Okay. And then we have, let's go with PWM. Actually this one too, I have to turn a switch to enable it. So again, if I don't enable that switch, we don't get anything. But this one, this is the only one of these radios that's actually comfortable to drive a car with. Back here a little bit. Okay, that's that. And then we've got NRF24. Have to be a little bit careful with this because these sticks are not very nice with the dead zone. Actually, this one's not too bad. I think this is one of the better ones. And looks like my steering is backwards here, but that's alright. So that's that. And then this one will take a moment to warm up. Oh no, there we go. So I think this way is going to be throttle. Yeah, it's forward. And back. So this could of course be a joystick or a potentiometer or something. I just got a bit lazy and I thought I'd use the accelerometer on there. And steering. Steering's a bit tricky to do without bumping the throttle. Yeah, but anyway, that's that. And then the last one is this one here, and to enable this, hopefully you can kind of see that. I'm not expecting this to be in focus there, but you should be able to at least make out that I've got 3 sliders. And if I enable this one by bringing it over halfway, now we can, so I'm just moving this top slider, and we've got steering. Can't do these both at the same time really. And then we've got throttle on here. A little bit hard to control. Come on. Oh, you got to stop in the middle for a bit with this ESC. There we go. Anyway, so I thought that was a pretty cool little demo, but if you're wondering what this could actually be useful for, there's a couple of things that come to mind. One is to make a buddy box kind of a system, because like I said, these have a pecking order. So if I turn, these are all off, I think, yeah. I think these are the top 2 in the pecking order anyway. So if I turn these both on, and I tell them that they both should control the car, that one does, but that one doesn't. But if this one turns that switch off, then this one does. So that's exactly what you need in a buddy box system for teaching somebody to fly a plane or a helicopter, but you don't need any wired connection between them, so it's just a little bit more convenient. The downside is, of course, you need 2 receivers on the plane or the helicopter. But the other thing that this could be useful for, because you don't need a wire between these 2, they could be in completely different locations. So like 100 kilometers away, if you wanted to do a mission, like a waypoint mission with a plane, one person could launch it with one radio and then switch off, or they'll go out of range probably anyway, and then somebody else at the other end could land it manually. So that would be quite useful for like a long-range delivery mission where you've got 2 people that are both capable of launching and landing the plane manually, and they're just like sending things backwards and forwards like on a fixed route or something. I saw a video a while ago on YouTube, I think it was somewhere in China, that they set up a waypoint mission with ArduPilot, and it took off from one place and then it landed at 200 kilometers away on a different island somewhere, like it was going over the ocean. And because they didn't have a system like this where you could just use 2 receivers or 2 radios to land it manually, they had to set up this really elaborate system where the plane would, as part of the mission, the plane would come along over a beach, and it would use LiDAR to scan the beach just to check that the altitude hadn't changed too much from what it was expecting from the barometer and stuff. And then it would like do that a couple of times and figure out like autonomously where it was going to land. But if they had something like this at the destination, somebody else could have just landed it manually, and that would have been much easier, I think. I might try that actually in a future video, see how that goes. Oh, and just before I pack this all away, I should point out that although I was doing this here with my laptop, that was mainly just for convenience to do it all together with the other radios and have some space outside to do it. But this could have just as easily been done on my desktop computer from the other end of the house. It's just anything that can contact on that IP address there. So in theory, if that Raspberry Pi on there could be made accessible to the wider internet, what I was doing here with the sliders could be done from anywhere in the world, in theory. And another thing I should point out is that since we're connected to the Raspberry Pi, which is connected to the S-Bus mixer over the USB, we can do all sorts of cool things like, hopefully, not sure how well this is going to focus, but if I turn that on there and I have my iBus ready to go, we'll see that we can actually see the number in real time that's running through all these nodes here. And this one here. Oh, whoops. Yeah. Anyway, yeah, so we're actually getting live feedback from every one of those little nodes in the program. That's the whole program there. I'll show you a little bit better on the, let me show you with this camera. That's a bit better. So the one on the left, we'll just look at the PWMs here instead. One of these is steering and one of them's throttle. And if I use the pistol grip radio, we should be able to... oh, got to turn this one off. Forgot the pecking order. Okay, there we go. So now if I turn this, you should see the one on the left is going from about 0 to 1, and then if I do throttle, the one on the right is changing. Yeah, so that just lets you see all the values of each of these nodes as they're running in real time. And for what we're doing here, we don't really need to see these values that much because we're actually inputting them with the radio control. But if these values were something like a temperature sensor or a humidity sensor or something like that, it might be more interesting to see, especially if you're in a completely different location. Could be quite handy, I suppose. Okay, I'll just give you a quick overview of the configuration that was running there. I'm still not ready to make any tutorials about this. There's a lot of things that will change yet, and with the price of STM32 chips being the way it is at the moment, I don't think anybody else is going to be getting this in their hands anytime soon anyway. I just wanted to give you a general idea of how much effort is required to set up something like this. So what we have here is a bunch of sets of things. Let's just zoom in on this bit here as an example. So this is iBus, and we have two channels there. We're using channel 1 and channel 2 of iBus, and they're being put into this thing here, which I'm calling, for the time being, I'm calling this a struct, but I think it might be better called group or something like that. It functions very similar to a struct in C or C++, so it's just sort of grouping these values as one thing that we can pass around to other parts of the program in a more convenient manner. And then down here we have channel 5. This is the switch that I was using to decide whether we currently have this method of radio control available. And we decide that by checking if this value is greater than 0.25 for this one. For some of the other ones, so if we just have a look at, I think the NRF24 one here, so there's some slight differences, but basically we have a set of three things. So we've got two channels for our actual control channels, and then some other method of deciding whether we're currently going to be using this radio control method. And for this one, instead of using a switch, it's just using the age, because the SBus mixer will be able to tell how long ago it has last received a packet from the NRF24 module. So in this case, if the age in milliseconds is less than 1000, in other words, we've had a packet within the last 1 second, then we have NRF available to use. So they're all very similar. PWM there. So I won't look at those in too much detail, and we already saw this one here, which was my sliders, like that. And then a default. So if none of the methods are available to use, we just have this default, which is going to be putting the sticks at the center of their range, so that's 0.5. And then we decide over here which one of those we're going to use. So we use this thing called a selector, and I've used names here, so this text name will find a node somewhere else with that name. In this case it's this one here, have Wi-Fi. And if that's true, then we use Wi-Fi, otherwise we use the default. And so this Wi-Fi one is like the lowest priority, because actually if we look at this end, this selector here will have the final say at the end of the chain. So iBus 1, actually I was mistaken about SBus there. I had two sets of iBus is what I was using. iBus is a little bit more convenient because you don't need to have an inverter in between the receiver and the SBus mixer. It's just plain UART connection. Anyway, so these little dots here, by the way, are just, if I turn that on, we'll see that there are connections being made, but it gets a little bit cluttered, and I typically don't like to have those showing too much while I'm working on it. It's just showing you that it's connected to something somewhere else with that name. Anyway, so once we've decided which of these things gets passed through, and the thing that we're passing, by the way, is one of these groups. So there's struct or a group, and it has, in this case, it can have up to 4 values. So we're either going to have this one pass through, or that one, and so on. So whichever one it is that comes out the end here, we then want to split up that struct with something called a struct member, and we can pick the first or the second member among that struct, and then that's what's eventually going to be given out as our servo output. So like I say, the struct, I'll probably call that group member, and we'll want to have larger than 4. At the moment it's a bit inconvenient in the system to make a variable number of these inputs, so I'll probably just make one that has 4 like this, and another one with 16, just for a really big one if you want to do something else. But like I say, I'm still sort of working on deciding how that's all going to work. But the reason why you'd want to do it with a struct is because if you didn't do a struct, you'd have to do it like this. So it'd be like that, and that would work too, but then you'd have a whole lot more of these lines going around all over the place, and it doesn't encapsulate the logic very well either if you're just doing it. Well, the reason, sorry, let me take a step back. The reason you'd need 2 of these is you'd need one whole chain of this just to handle the throttle, and then another whole chain of it just to handle the steering. So however many channels you were going to have, you'd need to have one massive big chain of this logic for each of them. So it becomes a little bit convenient. Let's say if we had 4 channels, we'd need that. And essentially this bit here is all the same. But if we come back to make a modification, like if we, let's say we want to put this around that way, then we'd have to set that up. We'd have to change that on all of our sequences, and it would just be really annoying. So rather than doing that, we're better off doing it this way. And that was what, 2? And this pin was 25, I think. I think I have this backed up, but just in case. I think that's what it was. Anyway, oh, and we have one more configuration. We had one more S-bus mixer, if you remember, the one that had the accelerometer on it that was sending information over the logging output, the serial modem. So this is the configuration that was running on that. We just have an IMU input for pitch and roll, and then we do a few simple operations on that. This pitch and roll angle is going to be in degrees, so we want to get that to a value between 0 and 1, and we do that by dividing by 180 and then adding 0.5. And then just to keep it safe, we also clamp it between 0 and 1, and then we pass that into the log output. This is on the transmitting side, of course, and then the corresponding input to there would be this one here. So this is where it's received on that side. Now this is probably a little bit confusing and I'm hoping that people, when I do eventually get some tutorials made in the future, these videos that I'm making here as a prequel almost will make more sense for people to come back and look at later on. Hopefully. Anyway, that's all I have for this video. Hope that was interesting. Thanks for watching. See you next time.